Thanks. So today I'll be presenting on citizen science opportunities. As Faye mentioned, my name is Joshua Lieberman. I'm a rising third year PhD student at University of Arizona, and I work on instrumentation for telescopes. But today I'll be presenting on a lot of um, well, in particular, one of the projects I was involved with in my undergrad, a citizen science project, but also all of the various citizen science opportunities out there that you can get involved with. So to start, what is citizen science? Well, it's largely defined by non-expert participation. What this means is that many of these projects are initiated by formally trained researchers, being uh, uh, scientists or professors, and then requiring participation from volunteers who don't necessarily have formal training in the given research field. And what that means is it's really ideal for undergraduates and, for example, high schoolers, because you can get involved in whatever capacity you want. And it's a really welcoming opportunity, like inviting in participants who don't necessarily have this formal education training in the given field. And these projects are comprised of many individuals, so involving large networks of contributors with more volunteers than professionals. And this is original research. So these are tasks that significantly benefit from large numbers of participants and also generate publications in which you can become a co-author on these publications by participating in many of these citizen science projects. So why do citizen science? Well, there are many reasons. I've listed just a few here. One is gaining experience collaborating as part of a large team. So as you may have learned throughout this workshop, a lot of astronomy is uh, not done in a vacuum in the sense that you are often working with other researchers. And so this is a great opportunity to work with team members from all over the world and a really good opportunity to connect with various researchers. There are relatively few barriers to entry into citizen science projects, although I'll get into that a little bit later on what I mean. And also, as I mentioned before, these citizen science projects contain opportunities to get published. So on this slide, I've listed just a few of the many publications in which citizen scientists are co-authors. So these are taken off of NASA's citizen science page on their website, and I'll include a link to that at the end. And I believe on one of these, even in this paper in the lower left on low mass co-moving systems, the first author actually is a member of the citizen science project, not a member of a research institution. So that's very cool. So I think under this one, the first author is affiliated with the Backyard World's Planet 9 project. So if you get heavily involved in these citizen science projects, you can generate publications out of them, which is pretty exciting. And so now I'm just going to highlight a few of these citizen science projects, starting with this small one that I personally was involved with in my undergraduate called Project Panoptes. And as you'll see in a few slides, there are quite a few projects like this one, but Panoptes involves it's a global network in which participants build low-cost robotic telescopes to look for transiting exoplanets. And they use these household cameras. So in this project, for example, it's a global endeavor. So going on 5 to 6 years, this citizen science organization has been partnering with the Royal Observatory in Bhutan. So students there have been building these Panoptes units. They also have these telescope units on in the Mauna Loa Observatory in Hawaii, as well as Northern Arizona University, and many other institutions around the world that are building these telescope units. And the unique thing about this particular citizen science project is it offers opportunities for both hands-on experience, but also data analysis. And this does get into a bit of the barriers to entry that I mentioned before. So with this type of citizen science project, if you want to be involved with the building of a telescope unit, all the documentation is on the Panoptes website, and I will share the link. However, there is a financial cost to entry in which to order all of the parts for one of these telescope units, it does cost around 4,000 US dollars. So that would have to be either like an institution sponsoring or self-sponsored. But as you'll see here and in the next few slides, there are a lot of opportunities to participate in this project and other citizen science projects without having your own telescope. So for example, in my undergrad, I worked with this citizen science project and I used the public data that citizen scientists had collected with these telescopes. And I worked with my professor in the citizen science organization to look at variable stars. And so there are similar initiatives to Panoptes that exist, and I listed just a few. One of these is called Exoplanet Watch, and this involves citizen science contributors who have telescopes and cameras, and they monitor these transiting exoplanets and submit their data to a public database where their data points are added to a light curve. And then AAVSO is similar and has been around for a very long time, in which amateur astronomers are contributing to these projects with their own telescopes. But again, as I mentioned, these do require some resources in the form of telescopes for the participants. So I'll now get into all the citizen science opportunities that allow for you to work with astronomical data in a way that's hugely impactful for the field. And you could actually start right now, like right after this meeting. So I was initially going to highlight a few different citizen science projects on the following slides, but I got a bit sidetracked after getting a bit more into the work that Rubin Observatory is doing. And I believe that this new telescope will be one of the greatest tools in citizen astronomy. So just a little bit about Vera Rubin and why I'm talking about this in a citizen science talk. This is the newest telescope to come online. It's an 8.4 meter survey telescope. It looks at the entire southern sky in 3 days, and it contains the largest digital camera ever built. So one image has the same resolution as 400 4K TVs. So that means it would take 400 of these TVs to display a single image from this telescope at full resolution, which is almost unfathomable. And this telescope produces 20 terabytes of data every night. And so just to kind of give a sense of how large these images are, this video here shows a single image that they stitched together over the course of 7 nights. And you can see just how many objects are contained within this one field in Vera Rubin. And in this video, this is one of the first light images from Vera Rubin. And you're going to see that you can zoom into various parts of this image and see even more details. And this image is also available on Vera Rubin's website. And yeah, so you can see a lot of the fine details in these images, and you can imagine that it is really difficult for researchers to process all of this data. And that's where it's really important for citizen scientists to come in. So just to go back to the slide that I showed previously, the Vera Rubin data, processing all of this information is a task that significantly benefits from large numbers of participants. And Vera Rubin's focus in particular is looking at transients. So that means, for example, short-lived events in the sky, so either supernovae or passing comets. And so they're going to utilize the help of all of these citizen scientists to process this data. And now I'll get a bit into how they're collaborating with a really powerful citizen science platform called Zooniverse. And so Zooniverse is a platform for hosting citizen science projects, not just in astronomy, but in all disciplines. And so professional resources professional researchers who want help from the public to analyze data, they'll upload their projects to this website. And so the Vera Rubin team is starting to do this. They're starting to upload data from their initial commissioning of the telescope in the form of projects that citizen scientists can participate in. But because Vera Rubin is producing so many images, this is really just the tip of the iceberg. And over the next few years, we're likely going to have many, many projects in which citizen scientists, so including undergraduates and high schoolers, for example, can work directly with this cutting edge data from the newest telescope. And so now we're going to, for the remainder of this talk, explore this Zooniverse website, and I'll show you this Vera Rubin citizen science project. So I may need to create a new screen share. I think, can people see my screen okay?
Yes.
Okay. So here, this is the Zooniverse homepage. And then if we click on Explore Projects, you can see all of the active citizen science projects that you could get involved in right now. And so you can see these come in all disciplines. So some of these aren't even in astronomy, but for example, recovering historical weather observations or helping to identify and count sharks. But I'm going to highlight in particular this very recent Vera Rubin citizen science project that came online. So if I click on this page, we're on their citizen science page, in which they have a short explanation of how this is the first data set released as part of this project. And then I want to just quickly highlight this one really cool section of every citizen science project from this website called the talk section, in which there are active discussions between the professional researchers and the citizen science participants about interesting objects they're seeing or really miscellaneous topics. And so another thing I want to just quickly highlight with these is one participant for this project recently asked if participants will be mentioned in publications. And so I feel this is something to look for if you're getting involved with the citizen science project on this website. I believe it's important for the citizen scientists to be credited with their work in the form of publications. And so a lot of projects will do this, but I'm not sure if all citizen science projects will credit the authors. So that's just something to look out for when you're starting your citizen science, if you want to invest significant time in a project and receive credit. So now just to get started, we're going to click classify, and then this gives us a bit of a tutorial on what we're looking at. So we're going to be in this project looking for asteroids or comets that display a tail or coma. And we're going to be going through these Vera Rubin images to see if these objects in the images may be comets. And it's just telling us, it's giving us a brief explanation of what is a comet and what might not be. And so you can see here in this example, to look for objects with these tails or with this coma, and also to be on the lookout for certain lookalikes that may be artifacts that aren't necessarily from a comet. So you can get started immediately. And so these are real images from Vera Rubin commissioning that likely not a lot of people have seen before. And again, I should clarify, because these images are so huge, this is just a teeny tiny snippet from one of these large Vera Rubin images. And you can see that largely how Vera Rubin identifies potential comets is through changes in brightness and objects that move against the background. So when I click play here, it's going to flip back and forth between two images where you can see this dot moving back and forth, highlighted here. And actually identifying whether or not these objects are comets is a bit challenging because I zoom in and it's hard to tell whether that is just a point source like a star or something that might have a tail or coma around it. So feel free to write your thoughts in the Zoom chat on whether or not you think this is a whether or not you think this object might have a dust cloud. And honestly, I don't really know. So it would be helpful. Okay, so one person is saying no. So okay. And as a note, you don't have to get these perfectly right on the first try because a number of people will be looking at these same objects. So for example, I'll choose no here. And then another feature that's kind of cool is you can also, if you click done and talk, it'll take you to this image. And for some of these images, there'll be discussions around them. And there are no discussions or comments on this image yet. And it might be in part because very few people have looked at it. So when you're vetting these objects, keep in mind that you'll be one of the first people to actually look at these particular objects, which is very exciting. And now to hit on a broader point, and something that I also had a question about as I was going through this, is Vera Rubin has so many objects in their images and so much data. Why don't they use machine learning? And I'm not a machine learning expert, I should clarify, but I believe the place for these citizen science initiatives, like having people identify these, is, for one thing, we're very good at identifying fine features in an image that machine learning algorithms may struggle with. And so it's valuable to use this human interaction with the images in complement with machine learning algorithms. And people in the chat may be able to weigh in a bit more on this, because I don't work a lot with machine learning or computer vision data, but I believe that's one of the motivations for these citizen science research projects. And so that's what I have as far as the citizen science talk. I'll just leave off with a few resources. So I will share my slides again. You can see that. Yep.
Yeah, we have some time for questions.
Okay.
Thank you, Josh. That was great.
Yep.
So maybe I can share my thoughts on citizen scientists. I worked with
Oh,
some
sure.
back in the K2 days, and the project was about, looking for strange transit-like planets in the K2 data. And traditionally, if you want to do this systematically using a computer, it's usually a match filter. But sometimes when it comes to comets, transiting comet, or so-called dippers, those are irregular signals. And usually looking by eye would be the ideal solution to identify those. So I work with a bunch of citizen scientists to help us identify those. And some of them end up in the papers that we wrote in the end. Uh, so if you want to get involved in science, I think this would be a great way to. I think they're still doing this for the test data. So Nitya asks, is micro observatory a citizen scientist project?
I think so. I've heard of micro observatory, although I don't know a lot about it. So I would have to check and get back to you.
Yeah, maybe I can chime in. If you do have, an amateur telescope, you can participate in some of these so-called micro observatory to observe for example, a large transiting planet. You don't need a large telescope. Something like 8-inch amateur telescope will be, more than capable of detecting a transiting hot Jupiter. And you can do it in your backyard. Can we join the working research team of these projects? Question from Kamal.
I can speak to that. You certainly can. I guess it also depends on the citizen science project, but that is how I got involved with the first citizen science project I mentioned. I sent an email to some of the organizers on the website because I was interested in getting involved. And a lot of the time, there are ample opportunities for undergraduates and high schoolers to join the team as interns. So I believe another one of the NASA citizen science projects I mentioned previously, Exoplanet Watch, they regularly take interns who help develop their pipeline for processing the data. So there are ample opportunities both on the telescope side, as they mentioned, if you have your own small telescopes to contribute data, but also on the data analysis and data processing side, there are ample opportunities to get involved.
Sounds good. So joining citizen scientists is one option. The other option is always, ask your local physics or astronomy faculty members if they have a project for you. After this workshop, you should have plenty of skills to get started. You know how to code, you know how to read a paper, and you can start thinking about real projects uh, at your local institution instead of doing a citizen scientist project. Of course, you can do it if you are, a freshman, and you haven't learned much physics. But if you're a senior, I think you should reach out to your local faculty first for real projects. So Avi, you had your hand up.
Yes. So I've heard a lot about Galaxy Zoo. Is that directly related to, or is Zooniverse just something along the same lines where you're having people identify images? And I saw that it said Radio Galaxy Zoo there.
Yeah, I believe Galaxy Zoo is affiliated with Zooniverse, although someone might be able to correct me if I'm wrong. I think that's one of the longest running citizen science projects. Yeah.
Yeah, thank you.
So Varad asked, how much accuracy can we give through AI models? If there are any, what are the issues with it? So my personal take on this is AI models are only as good as your training data set. And for many of the, Zooniverse project, the Comet project, we don't have absolute ground truth if an object is a comet or a galaxy of a certain type. And having citizen scientists help us gather a training set for the AI models. If a large number of people think this is comet and alert researchers in this field and validate it, then the object can be inducted to the training set as a real comet, and then AI model could use you know a training set like this to further identify other comets. But you have to start somewhere. You have to start building a training set from the beginning. So Ancalia, I've heard of an initiative called International Astronomical Search Collaboration. Is this similar to Zooniverse searches? Josh, do you know about this?
No, I haven't personally heard of this one, but it's possible that it is similar.
Yeah, me neither. So if you heard about it, do Google them and see what they are all about.
And as Faye mentioned, as far as connecting with faculty, you can also get involved with your faculty advisors in working on projects that use the citizen science data, because they do publish a lot of public data, which is very valuable to researchers. And so that was the project that I was involved with in my undergrad, was where we were using public data from these citizen science projects to monitor variability in young stars.
So Yajat asks, is this citizen scientist project help us? Does the citizen science project help us make us stand out while applying for jobs in research? If it is merely participation, probably not too much. But if your participation can lead to some publication, then it really helps. So personally, I've worked with a few citizen scientists myself, and some of my discovery were enabled by them. So, mere participation is probably not enough. You have, to do it really thoughtfully and spend, some time doing it so that you can stumble on a discovery.
And just to add on to that, I believe on the Zooniverse website, they have resources, I think under FAQs, addressing this very point, where they have a way of sort of quantifying the level of participation that may warrant co-authorship on the publication. For example, that one where the first author was actually a member of the citizen science project as opposed to an institution. That author must have contributed a significant amount, but they do have rough guidelines as far as how much you would need to contribute to become a co-author. So I would recommend looking into those guidelines on the website.
Okay, I think we are at the halfway through this live session. Maybe let's conclude here and move on to the next topic. Thank you so much, Josh.
Yep, thank you. Then I'll just show my email here, and I should be available in the Discord to answer any additional questions.